Welcome to this presentation. Here we will be looking at how the elements or the matter that we see in the universe is formed and relating this to the Bible as far as we can. Now, the main point of this is just to demonstrate just how remarkable it is, the processes that formed all the elements, particularly the elements that were made up of, how they were created, how they're formed, how delicately balanced this all is. People sometimes talk in terms of the universe being finely tuned for life and intelligent design, but please don't get caught up in particular phrases or terminology. Some of the discussion on this subject, even the people who are supposedly presenting intelligent design are not particularly intelligent in the way that they present these facts. But here we will be looking at established, well-known facts. Most of this is things that are known for many, many years. And we just want to demonstrate just the remarkable nature of these things. Now, first of all, apologies for the length of this presentation. There's a lot to get through. We're basically going to look at things like why there is matter in the universe for a start. What is the Big Bang all about? How did we get all the elements that we're formed out of? And how remarkable it is just that we have all the elements and all the matter in the universe that's exactly right for the conditions that are needed to create life. First of all, we should mention that inside the human nature there is this quest to explore, a desire to understand and investigate. This is deep inside the human heart. They want to find out what's there. It's expressed in Ecclesiastes 3 verse 11, where it says, "He has made everything beautiful in his time. He has also set eternity in their heart, so that no man can find out the work that God makes from the beginning to the end." So God has set eternity into the heart of man. Eternity, literally, that's vanishing point. That's something way in the distance. That's this desire. What's over that next hill? What's it all about? Why are we here? And what are we composed of? All the questions that people ask. But we see a beautiful creation. But inside this, there's the human heart, and deep inside that is a quest for eternity. Not just eternity from the natural point of view, from the physical universe, but also from the point of the spiritual. But here we're only looking at the physical side of things. In Genesis 1 verse 1, the famous words are, "In the beginning God created the heaven and the earth." And this might seem unremarkable at first until you stop and think that not all religions actually believe in a beginning. Some religions believe there was no beginning, that it's a continual cycle, one thing happening after another, and it just keeps repeating endlessly. Now, when we're talking about a Big Bang, and again, don't get caught up too much in the terminology of a Big Bang, just a theory of an expanding universe that started at a single point and just expanded outwards. That will just be abbreviating that to Big Bang, but don't get too hooked on particular names. But this, to me, is always spoken of a creation, an act of a God that created a heaven and an earth out of nothing, or out of whatever it was created from. Suddenly it appears. And not all religions believe that, But in Genesis 1, very first thing that it says, there is a beginning, and it was created. It should also be mentioned that atheists believing in evolution, and we're talking particularly more than 100 years ago, they believed in a infinite universe, infinite space and time, and they needed an infinite space and time, and so that the infinitesimally small probabilities involved in evolution of life can take place. And really the fact that life has appeared is beyond remarkable. The odds are so far against it, it's not even astronomical in size, it's way beyond that in terms of tiny. But in an infinite universe, that's possible. In a finite universe, a universe that's only 13.8 billion years old, then that's actually quite limited by our standards. It's huge, but in terms of eternity, in terms of the probabilities needed to create life, it's actually quite short. So we now have a Big Bang theory that gives a finite universe that's about 13.8 billion years old, plus or minus. They're still not exactly sure about the intricate details of how that happened. Did it start off as a bang, or did it just accelerate slowly? Was the expansion constant, or all kinds of questions? Was it dark energy, dark matter? That's all the fine print which we don't need to concern ourselves about. What we can see is that there was something suddenly appearing out of nothing, and out of this nothing we see an incredible universe. A few points to consider. If there's a beginning, there must have been some cause or reason for it happening. Things don't just happen for no apparent reason. Whatever happens, there's always a cause for it, at least in our experience, all our lives. Whenever we see something suddenly appear, if a light comes on, someone flicked a switch, that's the case always. And what we see is a universe operating according to order and natural laws that we can make some inferences about, and all kinds of laws, Newton's laws, and all the rest. And if there's a kind of order behind this, that suggests that there's a mind behind the operation of a universe. It's not just complete disorder. And if the universe designed, it also implies that there's a purpose or a direction behind it. It's not some sort of random thing, a child throwing toys onto the floor or whatever. It's like it's been designed. There's some reason for it. There's some direction, some motivation for it. Lots of misconceptions. I'll just quote a little bit from Wikipedia. The Big Bang is the origin of the universe. One of the common misconceptions about the Big Bang model is the belief that it was the origin of the universe. However, the Big Bang model does not comment about how the universe came into being. The current conception of the Big Bang model assumes the existence of energy, time and space, and does not comment about their origin or the cause of the dense and high temperature initial state of the universe. So it's saying the Big Bang model really is depicting the things after the initial moment of creation. It's only trying to cover what happened. And it's a remarkable picture too, what happened in the first second after the initial formation of the universe. matter was created out of the energy that was there, and eventually over time, over maybe 15 or 20 minutes, the matter forms atomic nuclei mainly of hydrogen and helium. Then as the universe gradually cools, all the hot plasma condenses into atoms of hydrogen and helium, and that took something of the order of 300,000 or 400,000 years, a long time. And at that point we're talking about a dark universe. Eventually the clouds of gas that are expanding outwards condense and they form stars, and that's when the first light appears, with the stars coming into existence. At these first stars, we don't know much about them. It's assumed that they're very big stars, very powerful stars, formed mainly of hydrogen and helium, so no other elements to any significant extent. So these burnt with an intense heat, and the universe in those days would have been a very hostile environment, massive energy being released throughout the universe, a relatively small universe, we have to say as well. There are a lot of constraints on the Big Bang model required for a universe capable of supporting life. So the Big Bang itself, it has to have properties that are exactly right for a universe that where life can appear. First of all, the expansion should be at precisely the right rate. If the expansion is too fast, the universe will collapse in on. If the expansion is too slow, gravity will just stop the expansion and pull it in on itself and collapse into nothing. And so it's a big flop after a very short time. If the expansion is too fast, all the matter just gets spread out so very thinly that there's no opportunity for any of the gases to form stars or galaxies. Another important thing there needs to be matter in the universe, and this might almost seem obvious, but we'll get to that in a little bit more. But you need to have matter and not just photons of light or energy or whatever. There needs to be solid material there, and the density needs to be correct. And on top of all this, you've got this expanding cloud of gas, but that needs to be slightly non-uniform so that galaxies and stars can form. So if the expansion is not fast enough, the universe collapses in on itself again under the influence of gravity. Expanding too quick, the matter is too thinly spread to form stars and planets. Now, the cosmic microwave background is electromagnetic radiation as a remnant from an early stage of the universe in the Big Bang cosmology, and this is a remnant, an afterglow of the initial Big Bang. Microwave radiation that you see in every direction that you look in space. And the remarkable thing about it is it's almost constant in every single direction that you look, except that there's a very slight non-uniformity. In 1992, scientists discovered that there is a very slight anisotropy, that's a non-uniformity in this radiation, roughly 1 part in 100,000, which is just enough to ensure the formation of stars and galaxies. If this anisotropy had been significantly smaller, the early universe would have been too smooth for stars and galaxies to form. If it had been slightly larger, galaxies would have been denser, resulting in numerous stellar collisions, so that stable long-lived stars with planetary systems would have been very rare. Now, coming back to this expanding universe, the Big Bang model, stretching out the heavens, it's interesting that when physicists describe it, the example that they like to use as a model or explanation is that of a balloon. If you gradually blow up a balloon and you imagine two ants or 2 points on a balloon, as you blow it up, the 2 points or 2 ants appear to be moving further and further apart. They're not actually moving, it's just the balloon itself that's expanding, and that's a two-dimensional representation of a three-dimensional effect that we see. But long before that, in the Old Testament of the Bible, multiple times the Bible has used another analogy, that of stretching out the curtain. In Isaiah 42 verse 5, thus says God the Lord, He that created the heavens and stretched them out, He that spread forth the earth, and that which cometh out of it, He that giveth bread upon the people upon it, and spirit to them that walk therein. In Psalm 104 verse 2, who coverest thyself with a light, as with a garment, who stretches out the heavens like a curtain. Isaiah 40:22, it is He that sitteth upon the circle of the earth, that stretches out the heavens as a curtain. So we see this terminology of stretching out the heavens like a curtain, and that is a very simple explanation of what we see with the Big Bang, the universe being stretched out, and this is a one-dimensional representation. You could say stretching out a curtain, 2 points on the curtain, 2 ants if you want to imagine specific things. As you stretch out the curtains, the ants think they're moving further and further apart, just like we think all the stars and galaxies are moving further and further apart. And bear in mind that what we're talking about is an Old Testament written in the Hebrew language, a very old language 4,000 years old or more, a language where the concept of a Big Bang or nucleosynthesis or none of those things would have been known, but here it is. It's depicting what we see in the heavens above, creating the heavens, stretching them out. Now there is one interesting unsolved problem in physics. Why the universe has so much more matter than antimatter. In fact, almost all the observable universe is matter. You can create antimatter with particle accelerators, but it doesn't last very long. Now the Big Bang should have produced equal amounts of matter and antimatter. There should have been total cancellation of both. Protons should have cancelled with antiprotons, electrons with positrons, neutrons with antineutrons, and so on. This would have resulted in a sea of radiation in the universe with no matter. Since this is not the case after the Big Bang, the physical laws must have acted differently for matter and antimatter, and the exact cause of this is still unknown. Even if the reason is determined or is understood, it's still a remarkable thing, but for the moment it's still unclear why this happened. So we don't say it doesn't matter anymore. We say instead it doesn't antimatter anymore. Sorry for this slide. Now in Job, chapter 38, verses 4 and 5, where were you when I laid the foundations of the earth? Tell me if you have understanding. Who determined its measurements? Surely you know. Or who stretched the measuring line upon it? So it's just a call for humility, a call to remember we didn't create the heavens and the earth, and we need to remember this. We need to remember this. We didn't determine the measurements, we didn't determine the size and the scope and all the properties of the universe. Psalm 102 verse 25, of old has thou laid the foundation of the earth, and the heavens are the work of thy hands. Again, important to be humble when you see these things. Some people are humble when they see these things. Some people are complete opposite. In Hebrews 11 verse 3, it says, by faith we understand that the worlds were framed by the word of God, so that the things which are seen were not made of things which are visible. So the worlds, the whole universe was framed, was formed by the word of God, and the things that we see are all made up of these tiny subatomic particles, subatomic particles that are not visible, at least not directly. You can see their effects. Genesis chapter 1 verse 2, it says, the earth was without form and void, and darkness was on the face of the deep, and the Spirit of God was hovering over the face of the waters. So the whole universe was without form and darkness possibly for hundreds of thousands of years. And here I don't want to be controversial and get into the aspects of a six-day creation, but for the moment just take it as read that we assume that Genesis 1 is talking about 6 periods of time, not actual 6 literal 24-hour days. Now we come to the famous formula E equals mc squared, a formula that everybody has heard of, the relationship between energy and rest mass, the mass of a particle when it's stationary. There's also kinetic energy, of course, and this was first proposed by Einstein. So energy and rest mass are related. So mass can be converted to energy. And if you want to see this taking place, there is the sun up in the sky doing that continually, converting something like 600 million kilograms into energy each second. So it's a massive fusion reactor, and it's effectively converting mass into energy because of the difference of masses of the particles that are being consumed and formed. Now the reverse process can also take place. You can take energy and create mass from that, and you can see that in, for example, in particle colliders like the Large Hadron Collider. They make massive particles, but even smaller particle accelerators can make smaller amounts of mass, and they do that from energy, basically. So in the Big Bang, energy is converted to matter and antimatter. In the first second after the Big Bang, matter and energy are continually being exchanged. So you've got that the matter combining with antimatter to create energy, again being used to create matter and antimatter. You can imagine a big soup boiling away, energy and matter continually being exchanged for the extreme length of time of about 1 second. Matter is being created by energy making pairs of particles and their antiparticles. Matter is being annihilated and energy created in the reverse process. So you get pair production, so energy comes in and you create a pair of particles, maybe a proton and an antiproton, or electron and anti-electron, and the reverse process also takes place. So what is antimatter? It's not some construct of science fiction. It's actually something that's observed by physicists. A particle and its antiparticle, for example, a proton and an antiproton, have the same mass but opposite electric charges, and some of its other properties are also the opposite. So it can be produced by particle accelerators and by radioactive decay. So some types of radioactive decay can actually make antimatter, usually in the form of anti-electrons or positrons. So a collision between any particle and its antiparticle partner leads to their mutual annihilation. So an electron and a positron annihilate and creates two quanta of energy in the form of, in this case, two 511 keV gamma rays. So it's very high energy that's produced. As we're talking about radioactive decay, bananas create antimatter. Just to bring it back to actual life, yes, bananas do create antimatter. A little bit of trivia for you. Bananas contain potassium-40, which is radioactive, and it decays by emitting a positron, which technically is antimatter, and that then annihilates very quickly with the electrons around it, produces gamma rays. So not only do bananas produce antimatter, they eventually end up producing radiation at very, very small levels. So the question is, where did all the antimatter go after the formation of the universe? Because we've just said energy should create equal amounts of matter and antimatter. So you've got hydrogen, proton with an electron, or antihydron and antiproton with anti-electron. They should cancel each other out. So after the Big Bang there should be equal amounts of matter and antimatter in the universe, but why do we only see matter? We don't see antimatter. Is there some galaxy out there composed entirely of antimatter? Some people have proposed that, but we can't find any evidence for that. So this is one of the mysteries in physics. There are clues as to why this might happen, but it's not really understood. In Psalm 19 it says, "The heavens declare the glory of God, and the firmament, the expanse of the heavens, shows his handiwork. Day unto day utters speech, and night unto night reveals knowledge. There is no speech nor language where their voice is not heard." In Psalm 139 it says, I'll praise you, for I am fearfully and wonderfully made. Marvellous are your works, and that my soul knows very well. So we're fearfully and wonderfully made. That's awesomely inspiring, wonderfully made. And this is the works of the Lord. So the question now is, what are we made of? No, not snips and snails and puppy dogs' tails. What are people actually made of? Well, there are a lot of different chemical elements that make up the human body. Hydrogen is the main one if you're looking at the number of atoms, or if you're looking at the weight. It's mainly oxygen and carbon. Other elements essential for life are nitrogen and calcium. We've all heard of calcium that are needed for the bones. Probably less well known is you need phosphorus, and an average person of say around 70 kilograms has nearly a kilogram of phosphorus, which is quite remarkable. But that's not the only element that's needed. You need sulfur, you need sodium, you need potassium, and chlorine and manganese, and iron. You've probably heard that you need iron in the blood, but iron is actually a very, very small fraction of the makeup of a human being. All these different elements are needed. And without them, we just don't work. There's no prospect of life, and no conceivable way of having life. So where does it all come from? All this carbon, oxygen, phosphorus, iron, etc. Where does it appear? And we have to note that the Big Bang is not enough. The Big Bang only produces gases, hydrogen and helium, not very useful for making solid objects. Carbon and oxygen and all the other elements that are needed for life were created in stars or similar processes. When the stars explode, they release the newly formed material which can produce new stars and planets. So not the first stars didn't have carbon and oxygen, so it's later generations of stars eventually burned and that formed that produced the carbon and oxygen. People have tried to understand where all the different elements came from, and this is a diagram from Wikipedia, all the different elements and the probable sources. Some hydrogen and helium from the Big Bang, lithium-7 might have come to some extent from the Big Bang, some extent from fusion reactions and other sources, beryllium from various places, cosmic rays would have had effects on and created lithium-6 and other things, exploding massive stars, exploding white dwarfs, and all the different elements. And some elements are very difficult to explain. And so they had to come up with the concept of merging or colliding neutron stars. Neutron stars are actually very dense stars that have collapsed in on themselves, so dense that the whole atomic structure collapses and the entire weight is just one entire giant nucleus. So the hydrogen in your body, present in every molecule of water, came from the Big Bang, and there are no other appreciable sources of hydrogen in the universe. The carbon in your body was made by nuclear fusion in the interior of stars, as was the oxygen. Most of the iron in your body was made during supernovas of stars that occurred long ago and far away in our galaxy, not a distant galaxy. The gold in your jewellery, if you have jewellery, was likely made from neutron stars during collisions may have been visible as short duration gamma ray bursts, hopefully not too close to where you were at the time, or gravitational wave events. Supernova events, explosions are in themselves quite complex things, where within a massive star you get an onion-layered shells of elements undergoing fusion, forming an iron core, and when that reaches a particular mass limit, it starts to collapse, and the inner part of the core is collapsed into neutrons, causing infalling material to bounce and form an outward propagating shock front. And the shock starts to stall, but is reinvigorated by a process that may include neutron interaction, and the surrounding material is blasting away, leaving only a degenerate remnant. And so you get supernova explosions that may form neutron stars, that may form black holes, but they throw out all this other material in the process. All this other material is thrown out that eventually is collected up and forms into our solar system, and forms all the materials that are needed for us in our daily lives. Everything that we have, to use a commonly quoted phrase, is star stuff. These supernova explosions, they're not just a sign of some kind of myth. You could see many examples of them, and the pictures that you see of these are quite stunning. Many of these supernova occurred thousands of light years away, and they really exhibit quite amazing and beautiful patterns. And we don't need to look into too much detail just to appreciate just that there is some amazing things going on out there in the galaxy. How do clouds of gas, a very ordinary thing, how do exploding clouds of gas form such objects of beauty? Again, quoting Ecclesiastes 3:11, He has made everything beautiful and appropriate in its time. He has also planted eternity, a sense of divine purpose in the human heart, a mysterious longing which nothing under the sun can satisfy except God. Yet man cannot find out, comprehend or grasp what God has done, His overall plan from the beginning to the end. And that's a quote from the Amplified Bible. And of course, people are still looking at these things now, of course, using the James Webb telescope to look into these things and to even look into the distant galaxies. In Psalm 8 it says, When I consider the heavens and the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? Just a reminder, what are we, this tiny creatures on this tiny speck of dust? We look out into space and we see things like this star called Eta Carinae, just one example of a star that exploded outwards. It actually exploded outwards in a dumbbell-shaped explosion, and this is thought to be about 100 times the mass of our star, but 5 million times the luminosity of the sun. So obviously you don't want to be too close to that. And the gas clouds expanding at about 1 million miles an hour, and now 1,000 billion miles across, 8,000 light years away, and predicted to supernova soon. It's so far away, of course, that it won't hurt us on our planet, but it may affect satellites in orbit around the Earth, and the same is true of many other supernova explosions that there's such immense power released when they explode that they can affect things that are in orbit around the Earth, unless people have gone to considerable lengths to harden the electronics. And 8,000 light years is an incredible distance, and for energy from a distant star to be able to have an effect at such a distance is utterly astounding, and reminds us what exactly are we compared with the massive forces out there in the galaxy. Now, the creation of the universe was no accident and required great wisdom. In Psalm 136 verse 5 it says to him that by wisdom made the heavens, for his mercy endureth forever. And in Proverbs 3:19, the Lord by wisdom has founded the earth, by understanding has he established the heavens. As we say, inside the stars many elements are formed. At the centre of the sun, the immense gravitational pressure produces a temperature high enough for nuclear fusion reactions to take place. In our sun, that temperature is around about 15 million degrees, and that's hot enough for fusion of hydrogen to take place. The surface of the sun is actually quite cool in comparison. It's only 5,500 degrees Celsius, and that can be measured by the temperature, by the colour of the sun. The actual processes going on inside the sun are depicted in this what's known as a Hertzsprung-Russell diagram. I think I've got the name right. Incredibly complex diagram. Temperature and luminosity, and there's also a third axis, you could say, which is the mass that's involved. Incredibly complicated process taking place. Burning of the hydrogen, then eventually forming a thick shell, and the helium starting to burn, and then a red giant forming, and all the rest, burning helium. One thing you need to notice is that with all this complexity, our sun sitting out there in space is burned at a near constant rate for billions of years, so that life can develop and grow and thrive on our planet. Now, if suddenly the luminosity had dropped by I don't know 50% or increased by 50%, suddenly life fries or life freezes. Suddenly our planet is no longer in the Goldilocks zone. So somehow we've got a star that burns at a near constant temperature, and that might not sound strange until you think about if you build a fire, you light a fire when you put lots of firewood on it, and initially it's relatively cool until it takes hold, and then it burns really brightly, and then it cools off. And so there's no real concept of it just burning at a steady rate. It just flares up and then cools down. But our sun, for billions of years, is burnt at a near constant rate, just as well. So what happens inside a sun? Firstly, is inside a star, I should say. First of all, hydrogen is burned. Hydrogen is the most common element, and that's gradually burned, releasing energy. Relatively slow process, and it creates more helium in the process. Eventually the hydrogen is used up, and the star again collapses under its own gravitational pressure, and it gets even hotter, and then it's hot enough for the helium to start burning, and then that can can create carbon and oxygen. And the carbon and oxygen are needed for life, obviously. No carbon, no oxygen, no life. They're obviously critically important. As is also hydrogen, not to understate the importance of hydrogen in our existence. Now, the burning of hydrogen in stars actually takes place through a relatively weak interaction process. It's actually called the weak nuclear force, where two hydrogen nuclei combine to form deuterium. And if the nuclear force was weaker, the strong nuclear force, so the force that binds the nucleons together, if that was weaker, no stable deuterium could be formed. And if that same nuclear force was stronger, a hypothetical particle called the Di-Proton could be formed. So the sun and all the stars fuse hydrogen to make heavier elements. The first step being the burning of hydrogen. So inside the sun, this diagram depicts first of all the hydrogen coming together and making deuterium through this very weak interaction. And just to show how weak it is, in our sun it takes on average 1 billion years for that reaction to take place. Obviously there's so much matter inside the sun that 1 billion years, but a massive amount of material is enough to compensate for this very, very slow process. But after the deuterium is formed, it's rapidly consumed by combining with protons to make helium-3, and that takes on average about 4 seconds inside our sun, so the deuterium lasts a very short time, and then the helium-3 combines with other helium-3 to make helium-4 and spits out 2 more protons. And that's a relatively slow process because there's not a lot of helium-3 inside the sun, so it takes a while for the helium-3 nuclei to find each other and make helium-4. Coming back to the question of the Di-Proton, we say, so what? If a strong nuclear force was a little stronger, 2 protons could combine to form a Di-Proton, and the existence of a Di-Proton would result in a different, very efficient pathway to produce helium. So what does that matter? A Di-Proton would exist if a nuclear force was about 2% stronger, and the reaction rate for burning hydrogen will be about 10 to the power of 18 times faster. I think that's 18, yes. All hydrogen would have been consumed in about 3 minutes. So instead of a sun burning steadily at a constant rate for billions of years, the sun burns up in 3 minutes, and obviously vaporizes any planet in that time. No opportunity for life anywhere. No long-lived stable stars. No hydrogen remaining. All the hydrogen burns up. So no hydrogen means no water, no hydrocarbons. So no carbon-based life. It's all gone. Not to mention there may not be any hydrogen left after the Big Bang, but this is just discussing what would happen inside a sun, inside a star. Now, when we come to the burning of helium inside stars to make the elements carbon and oxygen, this is one of the very remarkable things. This can only proceed by an extremely delicately balanced reaction. It's hard to really describe just how delicate the balance is without explaining a little bit more about nuclear physics, which I'm sure most of you are pleased to hear a little bit more about nuclear physics. We all want to know more about nuclear physics, of course. At higher temperatures, temperatures enough for the helium to combine, and after the hydrogen is mostly been burnt up, helium-4 can combine to make beryllium-8. But beryllium-8 is unstable. It only lasts for a very short time. In fact, it only lasts for a time period of about 10 to the minus 16 seconds. But in that extremely short time, there's a possibility that another helium-4 nucleus comes along, combines, and makes carbon-12. And this is known as a triple alpha reaction, because helium-4 is also known as an alpha particle. So our universe is a triple alpha universe because of this process that makes carbon. And then some of this carbon, not all of it, but a proportion of it, can actually burn with helium-4 to make oxygen-16. And when the temperature of a star is hot enough to burn helium, it produces carbon and oxygen. Now the creation of carbon-12 only is there because of a resonance in the reaction between the helium and the beryllium. There's a resonance at exactly the right energy for this to take place to form carbon-12, the right energy and the right spin and parity, I guess, as well, you'd say. So that's the energy level within carbon-12 at about 7 MeV, and this has been noted as being astounding, and it's been known for 60 plus years, just how remarkable this thing is. Now, the same resonance doesn't happen with the burning of carbon-12 to make oxygen-16, and due to a lack of a resonance, some carbon-16 is produced via subthreshold resonances, resonances just below the energy level, but not enough. But then we're fortunate, the oxygen isn't all burnt up to make neon, so you have to consider just how delicate this balance is. This beryllium that only exists for 10 to the minus 16 seconds, delicate, precise energy level in carbon-12 to make carbon-12, then slightly different properties in oxygen-16, so some of the carbon goes to make oxygen, and then neon that's there in such a way that you don't burn up all the oxygen. You imagine things change, either no carbon is formed, or all the carbon is formed and burnt up, and eventually it goes straight away through to neon and heavier elements, and you've got nothing left to make people. No carbon, no oxygen, all consumed. Remarkable, the properties. And as I say, this is something that physicists, nuclear physicists, have been well aware of for many, many years and have commented on, and people have been astounded by this. Carbon and oxygen stating again, because we have to state these are the basic building blocks of life. Without this reaction taking place in stars, there'll be almost no carbon and oxygen in the universe. And if the strength of a strong nuclear force was different by about plus or minus 0.5%, this reaction could not proceed. No building blocks of life, no nothing, it's all over. And a word from two eminent scientists in connection with the resonances between helium, beryllium and carbon. Gribben and Rees in 1989 wrote, "This combination of coincidences, just right for resonance in carbon-12, just wrong in oxygen-16, is indeed remarkable. There is no better evidence to support the argument that the universe has been designed for our benefit. tailor-made for man. So these are physicists. They're not just physicists, members of a physical Royal Society. These are leaders in their fields. Nobel laureate Arno Penzias, sorry for my pronunciation. Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. So this is what scientists say. This is not some invention of some crazy coot. This is what the real experts say. A quote from Sir Fred Hoyle: "Such properties seem to run through the fabric of the natural world like a thread of happy coincidences, but there are so many odd coincidences essential to life that some explanation seems required to account for them. The simplest explanation for it is that God created the universe, but people have tried hard to come up with alternatives. But we can say the universe appeared finely tuned for life." Again, don't get caught up with particular phrases like finely tuned, because sometimes people use this and get carried away, but this is a reasonable description, exactly designed for human life. And the many different properties, the forces of nature, all have to be balanced. The weak force, the electromagnetic force, the strong nuclear force, the gravity. So the gravitational force has to be exactly right, so that it's not too strong, not too weak. The electromagnetic, all the rest. We could talk about this in a long time. They all have to be in exactly the right proportions. And then all kinds of forces of nature that have to be combined together. Many fundamental constants all have to be combined for things to work out exactly correctly, and we don't have time to discuss it all. Even things like the mass of a neutron, the proton and the electron, exactly right for our universe. Now, coming back to scripture in Romans 1 verse 20, it says, "For since the creation of the world his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." So people really have no excuse for seeing the remarkable things that are there, the invisible attributes, the invisible forces of nature, the incredible coincidences that are there, the nature of our universe, his eternal power. All of these things leave people really with no excuse, but some people really don't want to believe, and it's not that they've got a better alternative, it's that they really refuse to accept it. So they come up with possible explanations. So some reactions to such amazing coincidences and the evidence of a design, they come up with things, the anthropic principle, and basically that says that without the coincidences we wouldn't be here to puzzle over them, so that's why they're here, because if we weren't here we wouldn't be here to puzzle over them. It's a kind of circular argument which seems very bizarre. Then we get theories about multiverses, which is all possible universes exist, and we can only observe a universe in which we can arise, and there's absolutely no evidence for multiverses. People talk about such things glibly, especially in science fiction movies, but there's absolutely no evidence for a multiverse. We only see one universe and evidence for one universe. The simplest explanation is always the best. The simplest explanation: we have a creator God who formed and created the universe. All the other explanations are much, much more complicated and convoluted and illogical. Now, if we look into the Gospels in John chapter 12 and verse 28, there's an occasion where Jesus was speaking and he says, "Father, glorify your name." Then a voice came from heaven saying, "I have both glorified it and will glorify it again." There the people who stood by and heard it said that it had thundered. Others said, "An angel has spoken to him." So this booming voice coming from heaven saying, "I have both glorified it and will glorify it again," and the two groups of people. One said, "An angel has spoken," another said, "It thundered." And this was the two reactions that people had to the events that they heard, much like the two reactions people have when they see the remarkable coincidences. Some don't want to believe, so they look for an alternative. It was just thunder. Some people are willing to believe, and so they say this was the voice of God. And if a coincidences that we see in nature are not the voice of God, then what is? In Psalm 89 verse 11, "Heavens are thine, the earth also is thine. As for the world and the fullness thereof, thou hast founded them." Psalm 96 verse 5, "For all the gods of the nations are idols, but the Lord made the heavens." So, thank you very much for listening to this presentation. I hope you've managed to get through all this. I know that there's a lot to take in, even when you understand all the nuclear physics. It is remarkable things that have happened. And yes, I am someone who understands the nuclear physics. That was my training, and I've got a PhD in nuclear physics. Not that I want to boast about that, just to say this is true and this is really the case. Thank you.